which is such a good point. You had mentioned, oh no, JC, you mentioned, do statistics always have to have margins of error? And the answer always is yes, they have to, because there's always, the word error isn't a bad thing. It's a necessary thing. If you draw a sample from a population, I never answered the first question you asked over break. She mentioned this, that you're never going to see the sampling distribution curve that we saw on that Excel sheet, and you're 100% correct. And then you were worried about why it's even there. And I referred back to 243 with X double bar. So if you draw every single possible average that's out there, and then average those, you get that curve. But you can't. Go ahead, go ahead.
You can or you can't.
You can't figure that out. Mathematically, that's where the bell curve comes from. Mathematically, if you draw every single possible sample from a population, which you cannot do, because in order to do that, you have to know your population. Now, when I'm using the word population here, JC, I'm not talking about real estate, I'm not talking about penny spins, I'm talking about a set of numbers that exists.
But we're applying our sample.
Yes, exactly. You're pulling a sample from that. You get one of those many, many, many sample averages. And that's the one that moves around, depending on you.
I'm having a hard time with that being okay.
It has to be okay, because it's all we got.
Oh yeah, it's because it's already here.
It's all we got, my friend. And you have to be okay with error, and you have to be okay with being off once in a while. We'll deal with all this in this class. That's what this class is all about, is dealing with that offness. Promise. Great question. Then you go. Yes! You can do it for us. I'm going to put it on the board, because I want everybody to see what we're doing while we're doing it.
You can do it.
Well, no, I want you to do it. See how it's corded. It's not wireless. Okay, friends. What I've got here is some data old and new, and I figured we'd do it together to make sure that we're okay with button pushes. Okay? So, back in January 2010, took a random sample of for sale homes that were on the market at the time. Turns out that 702 that I sampled, 65 were in foreclosure. So I was interested in homes that were up for sale that were in foreclosure. Why did I care about this in 2010? That was right 6 months or less past the chaos that was vendor real estate in 2010. After 2007, 8, 9, it was just chaotic. It's all get out. Wild West. So I was interested. Let's see if there's anything interesting going on. So of the 702 that I sampled, and I gave you sources down here as to where I pull this stuff from. 65 were in foreclosure. If you had to tell someone what is the for sale foreclosure rate, or the foreclosure for sale rate, or however you want to define that statistic parameter, I guess, what would you tell them?
So 65 of the 700?
That's right, of the 702, 65. That is a good question, actually, Tim. Did you hear what Tim said? He said, do you mean 65 of the 702, or do you mean that 65 were in foreclosure and 702 were not? That's important to distinguish. It is 65 out of the 702, which means about, what, 640 of them or so were not in foreclosure. Good, foreclosure sales, thank you. So but it's important to know that I have not given you, I've given you X and N. I have not given you X and N minus X, if that makes sense algebraically, hopefully that does. And you gotta read carefully, because sometimes they'll say, you know, things like, for every boy enrolled, there are 4 girls. That means 1 out of 5 are boys, yes? Not 1 out of 4. It means the ratio is 4 to 1, which is actually 4/5 to 1/5 as a total. So read carefully. Thank you for that, Tim, for pointing that out. Yeah, good. All right, what would you tell me?
About 9%.
Okay, we'll just stop there, would you? Foreclosure for sale rates. Actually, I love the word about. I love that, by the way. So we're talking about January 2010 first, yeah? So if I wanted to know the proportion in January 2010. I'm here plus or minus, right? Making me happy. Sorry. Boom! The first thing you guys probably did was you said, okay, it's 65 out of 702. That's like 10%-ish, yeah? Ish. I'm going to round that off to 10%. But you wouldn't just say 10%. Of course the news media will. Of course they will. 10% foreclosure rate for sale. No. Not unless you counted every single house. If you counted every single house on the market that was for sale right then I would believe that it was 10% or whatever it is, exactly. Because there would be no margin of error. But the fact that it's a sample implies there has to be, doesn't it? There has to be a mark of error. Say that again. No.
Oh, sidebar. How the media would say.
Oh, good, sidebar. I love sidebars. I love them. Good, good. All right, so let's calculate, shall we? We're not going to say that it's exactly equal to 65 over 702, because it's not. Because if we drew a different sample of size 700 and whatever it was, we probably wouldn't get exactly 65 homes again. Fair enough? Good. So what are we going to do? Megan, help me. I need an interval. Good. She went to 1 prop z int. Yes. Yes.
65.
While she's doing that out of? While she's doing that, I'm going to put a number line on the board here. Crap, one too big.
Just a 12 on ours.
What's that?
Just a 12 on ours.
Here, I'll just do 0, 1, 2. Skip every other one. That's considered 0, 2, 4.
How many six figs?
Say again?
How many six figs?
It's a damn good question, which technically speaking, what would it have to be? This gets tricky. This gets tricky because sig figs are something I don't remember very well from chemistry. I don't think you're allowed any more sig figs than any of your data going in.
It depends
But the problem,
if you're adding or doing multiplication.
we are.
So if you're doing multiplication, it's by how many sig figs are in the smallest amount that you're doing. If you're doing addition, subtraction only, then it's by the lowest, like tenths place or hundredths place.
Got it. So technically speaking, since we are doing multiplication, aren't we, on this? So on the original number, we had 65 and 702. But does it change with the type of data, though? Because discrete, I mean, if you think about it, discrete data can technically have infinitely many sig figs if you just keep counting. I mean, if I count to 100,000, I get 6 sig figs. Because I counted to 100,000, there's 6 numbers that all mean something. I wonder if that's, let's call it 1 decimal, call it good. I mean, I have no idea what to do with this data. I don't know if it's a data difference. Let's just call it 1.
Donna did 3, so this.
That sounds great. I don't think 3 is very meaningful in this case. I think 1 is probably pushing the limits of what we should do. Because I think it does vary on the data you're putting in. I honestly think that matters. And because it's discrete, I'm not really sure if precision's an issue. We'll call it 1. We'll go to 10th place. That seems to make us sort-of-ish consistent. There! So you will not say, although it's tempting, to say that the foreclosure for sale rate is 9.25 or 9.3%. Oh, so technically we are going to 3 decimal places. In 1 place as a percentage, but 3 as a decimal, which would be equivalent to the same thing. There we go. I like that. So 9.3% would be the center of the interval, but you wouldn't report that as the foreclosure for sale rate because that pretends it's a parameter. That would only be the case if you counted all 702 houses, if that's all there were, and 65 of them were foreclosure sales. So you slap the margin on there.
So in 243, we said on average, in this case, it'd be on average about 9.2.
9 point, you're right.
As little as,
I love it.
and then as.
I love that.
Okay.
As little as or as much as.
Interpret it.
I love that, sister. That's perfect. That's perfect. Absolutely perfect. Absolutely perfect. So I'm going to turn this off briefly. Now, 7.1 to 11.4. I'm going to put it here. That's a percentage. Let me put a percent sign on there. So what that means is, and I'm going to start saying this as a statistician would say it, because this is what you have to say this because this is what you'll actually hear in proper studies. I am 95% confident that the percentage of houses up for sale that are in foreclosure is at least 7.1%, but no more than 11.4%. That's what you just said, JC, in your own way, which was also correct, FYI. All right? So I'm going to make this green on the number line below. You don't have to make it green, and it's not important to make it green as long as it's indicated on the number line somewhere. So it's at least 7.1%, which is ish here, and maybe as high as 11.4%, which is going to come over here. You do not know where it is in that interval. Hell, you don't don't even know with 100% certainty if it's in that interval, do you? 95% of the time, if you do an experiment like that, my voice is cracking a lot today, I apologize. I drank a lot of pool this morning and it's crackly. 95% of the time, if you run studies like this, you're going to trap P inside your P hat plus or minus your margin of error. So all you can say for certain is, I'm 95% confident it's in there somewhere. 95% confident it's in there somewhere. That's all you can say for sure. And it's not even for sure. It would be for sure if it was 100% confident. And this might make you feel cheated. You're like, my God, you can't say anything with certainty. Well, that's why it's called probability. It's never certain. This is why I was so excited on that last project you guys did in 243, false positives, false negatives. Just because you test positive on a test doesn't mean you have whatever you're testing for. It could be falsely positive. Okay? It gives you an idea of measuring the gray in the world. I get on my bike every day and ride to school, ride to work. There is no guarantee, just based on the fact that I haven't died yet doing that I'm not going to die tomorrow doing that. All I can do is I can analyze the risk and minimize those probabilities via safety, i.e. probability, and statistical methods. That's all it is. It's all gray. It's how to measure the gray. Cool? Let's do a couple more, and then we'll call it a day. Let's finish the quiz out. Here we go. Here we go. Let's start and stop again, or stop and start. Yeah.